So now let's start breaking these guys down according to mass. So we have a main sequence star, and if we have a star that is between 0.08 to 0.4 solar masses, we have what's called a class M star. And on the HR sequence, that would show up on the lower right of the chart. All right. Well, what are these? Well, these are red dwarfs. They have the lowest surface temps and the lowest core temps. Their surface temps are somewhere in the range of 4,000 kelvins. And lowest core temps. But I hasten to add, remember, these stars do nevertheless have hydrogen fusion going on in their core. So we know that that core is at least 10 million kelvins. That's the critical temp to trigger hydrogen fusion. So yes, they are the lowest core temps, that is true, but they are still at least 10 million kelvins at the core. They have the longest lives. We estimate the lifespan of a red dwarf to be somewhere in the range of 200 billion years. And so the question is, have we ever seen a red dwarf die? And the answer is no. Why? Well, because the universe hasn't been around long enough. The universe is just a little under 14 billion years old. These guys got a lifespan of 200 billion years. So yeah, we haven't been around long enough to see one of these guys die yet. Pretty amazing. They are the most common type in the galaxy. We estimate roughly 85%. And this is a recent discovery. It's only been within the past couple of decades that we've come to understand just how numerous they are. Yeah, they're all over the place. Well, why didn't we know that before? Well, because they're dim. They're really hard to pick up on a telescope. They're the dimmest stars out there. All right. So they are limited to hydrogen fusion. And recall that hydrogen fuses to helium. And in other stars, we can get to a point of helium fusion, but not in a red dwarf. There just isn't enough mass. So it's limited to hydrogen fusion. Insufficient mass to trigger helium fusion. That is 10 to the 8th kelvins. Okay. And here's something that sets red dwarfs apart from all other stars. Other stars don't do this, but a red dwarf does. The helium is transported from the fusion core by convection, and the cooler hydrogen sinks until all the hydrogen is used. And you see that little diagram there in your book. So yeah, the helium is transported from the fusion core by convection, and the cooler hydrogen sinks down to the core to begin fusion until all the hydrogen is used up. They're just like these red dwarfs are like a boiling pot of water. So the bottom of the pot is heated up on the stove. It rises by convection. The cooler water sinks, and it just keeps churning and churning and churning and churning. And that's what these guys do. They churn and churn and churn until all the hydrogen is used up. Their luminosity, their brightness, is roughly, on average, about 3/100ths the luminosity of the sun. They are the dimmest and hardest to detect. Yeah, they're in a class all their own. Okay, we'll pause here and go on to the next page.